So, hi everyone, I am John Michael Pipito, and for today I am going to show you on how to calculate or use the composite great circle sailing. So first, we have these examples, which is latitude 1 is 35 degrees and longitude 1 is 75 degrees, latitude 2 45 degrees, and longitude 2 3 degrees west. And for the latitude of vertex is 48 degrees. So we're given now the example, and first we're going to calculate for latitude vertex where the track meet. So for that you need is cosine p1 is equals to tangent L1 divided by tangent LV. So we tangent L1, which is but first we need to calculate the longitude. So for the longitude, we have longitude 1 is equals to 75 degrees west, and for longitude 2 we have 003 degrees west also. So as rules given by this organization is we need same sign, so same sign subtraction, and different sign is addition. So it has the same sign, so we need to subtract. So 75 degrees minus 3 is equals to, and our d long is equals to 72 degrees east, because the line of arrival is going east. So next is we need to get the cosine p1 or the long v1. So to get that is cosine p1 is equals to tangent l1 divided by tangent lv. So we have tangent 35 degrees divided by tangent 48 degrees. So we get there 0.6304969925. So here is the answer of getting the tangent 35 degrees over tangent 48 degrees. So we need this to shift cosine, because we need to get the inverse of this value. So for the tangent, that is we get 50 degrees point 50 degrees and 54.91 degrees. So for the value, for the sign is we depend on the d long. So it's east, so we need to put there east. So this is our p1. So to get the long v1, so long v1 is we need this to subtract with the longitude 1. So longitude 1 is equals to 75 west. So it has different sign, so we need to subtract. So 50, so long v1 is equals to 24 degrees and 5.09 degrees. So we will use the sign for the greater value, so which is 75 plus the greater value, and its sign is west, so we need to put there west. So this is our long v1. So next is we need to get the long v2. So to get the v2, so we will mark it A, and for V for long v2. We need to get the long v2. So to get that long v2 is we need to So using cosine P2 equals to tangent L2 divided by tangent LV. So same as we did to, so we get tangent 45 degrees divided by tangent 48 degrees. So the result is 0.8 54629 65162. So we inverse that, inverse cosine. So the value we get is 31 degrees 16.87 degrees. So we will, so for the value there is we need the inverse of this value, so contrary to the D law, so which is east, the D law is east, so we need, so the sign there is west, so that is west. So this is our V2. So when we get the long V2 is we need to subtract it with our longitude 2, which is 3 degrees west. So it has the same amount, I mean it has the same sign, so we need to subtract. So I mean add. So our long V2 is equals to 34 degrees 16.87 degrees. So they are the same, so west. So our long V2 is, yeah, choose. So for the next is we need to get the initial course. So to get the initial course is we need to find the initial course, and to get the initial course is equals to sine angle A is equals to cosine LV divided by cosine L1. So the value there is equals to cosine 48 degrees divided by cosine 35 degrees. So the value we get is 0.5 2105 163.763. So the inverse that we need to use the inversion, so because it has sign there, and we need to this of the sign there, the sign. So it's equals to cosine, north 31.4 degrees east, because north sign is north, and east because it is the hour is in the east in this, so northeast. So next is the into the true course, it is located to the quadrant 1, which is as east. So initial course is equals to 51.42 course. So for the final course, we need to use the cosine LV, same as we did in cosine L2, the over cosine LV, cosine 48 degrees divided by cosine 45 degrees. So cosine, and our answer is we get south 22.2 west. So south because it is contrary to the north. Contrary to the north, and west is the value of our LV2, which is the west. So it is located at the quadrant 3, so we need to subtract 180 degrees. So V2 minus 180 is equals to 157.88 degrees true course. So that's it. So next is for the AV1. And to calculate the AV1 is equals to sine L1 with sine LV. So we get there 0.732508984451. So need this to inverse cosine. So cosine inverse this is 42.9028, and we need to multiply it times 60 because it is need to convert in nautical miles. So AV1 is equals to 47 degrees 47 nautical miles. So next is we need to get our BV2. Get our BV2 is equals to cosine BV2 equals to sine L2 divided by sine LV. So we get the value of 0.870814888491. So inverse of cosine, so inverse that is 29.4465, and multiply 60 again, and we will get the BV2 1766.79 nautical mile. Okay, that's it, nautical mile. So next we have space there. So next we will get the P3. To find the P3 is equals to D long is minus 2 P1 plus P2. So our P1, which is this, the 50 degrees, and the P2 is this, or P2, this one, this one, and this one, P1. So P1 D long is 72 degrees, so we will get, if we will subtract that, we will get 72 degrees minus 82 degrees 11.78. So in total P3 is equals to 10 degrees 11.78. So here's our P3. So next is we need to get the V1 and V1 V2. So to get the V1 V2, this V1 V2 is equals to P3 times 60 times cosine LV. So cosine LV. So P3 is 10 degrees 11.78, and times 60 times cosine 48 degrees. So next is we multiply it, and we will get the answer of 409.36 nautical mile. So we have now the V1 V2, the PV1 and PV2. So next is we need to get the total composite distance. So to get that is AV1 plus AV plus BV2 plus this, the V1 V2. So we have 2574.17 degrees nautical mile, no degrees, plus 1766.79 nautical mile plus 409.36 is equals to the total distance is 4750.32 nautical mile. So here's our total distance. I hope you learned something, and thank you for watching. So for today again is I will tell you or I'll teach you on how to get the bearing and the distance of your course. So if you are given the coordinates, which is the latitude and longitude, like and you're going to plot it, is you need first to get where it located from. Like for example, you have longitude of 35 and 45 degrees, 35 degrees north and 35 degrees west. For example, there we have a 6 degrees north and 5 degrees west. So we will count off. So this line is our latitude and this line is our longitude. So we have 6 nautical miles north and 5 nautical miles west. So north, we will count 1 to 6, 1, 2, 3, 4, 5, 6. So 6 in this line where 6 is located. So then 5 degrees west. So west is in this side 1, 2, 3, 4, 5. So west and 6, 5 is where they meet. So here they meet over there. So this, and the second position is located at 9 nautical miles and 9 degrees north and 10 degrees east. So 10 degrees north, which is there, 10 degrees north and located, and 9 degrees north and located 10. So they go there. So this is their waypoints. So when we are going to connect that from there to there. So to get their bearing is with the help of the parallel ruler. We are now having any parallel ruler, but I will tell you how we are going to measure it with parallel ruler and then transfer it in where the course are going to. So with the use of this azimuth circle, you will locate your bearing because it has the numbering of 360 from 0 until 360 degrees. So since this waypoints that as is that the waypoint or the course of the ship is going there, so this is the ship's going there. So 45, 6, 7, 8, 9. So our bearing is 49 degrees true course. So our bearing, and for the distance is with the use of what do you call that, with the use of compass divider is you're gonna measure them and measure it in the line which is indicated at your map. So today we are only making a substitution of the map because we don't have that map. So that, and when you're going to measure this, like this, so I'm gonna measure it. So it's located over there. So 2, 3, 4. So 10.4 nautical miles. So the distance is 10.4 nautical miles. So and when you are going to put the distance and bearing, so this to put the distance and bearing is above the line you created with the use of 2 waypoints is you are creating a line. Then at the top of the line is the time of their course. So let's say that this waypoint happened in this happened in 9 900 hours, so 900 hours. So this is their time, and below that is the bearing under course. So first is the bearing is equals to 49 degrees 2 course, and their distance is for a 10.4 nautical mile. So that's it. That's simple as that to get the bearing and distance of the ship's course. So that's all. Thank you.